to Chapter 1. We are looking at Lesson 1.1, Modeling and Equation Solving. And so when we get to the end of this lesson, we're going to be looking at solving some various equations. Some of them, a little trickier than just the basic algebra type equations. But before we get that, we're going to look at solving problems using a couple of different types of models. Okay, we have a numerical model to look at. We have algebraic models, graphical models, just different ways to solve problems. As I said, the graphing calculator will be helpful because when we look at one of these, I think it's part of the numerical model, we can look at a way to analyze data using our calculator. So, when we talk about models, mathematical structure that approximates phenomena for the purpose of studying or predicting behavior. Okay, so taking a bunch of numbers, data about something, examining it, digging into it. And that's what we're going to do with some of these. Now, the first type we're looking at is numerical. We're looking at the numbers here. So the most basic kind of mathematical model in which numbers are analyzed to gain insights into phenomena. Let's look at example 1 here. Example 1 is just based on the chart that is provided. The numbers in the table to the side show the growth of the minimum hourly wage from 1955 to 2005. The table also shows the minimum wage adjusted to the purchasing power of $1996. Answer the following questions concerning the data. So take a moment, check out that table. It's minimum hourly wage. There's years. There's minimum hourly wage, and there's purchasing power in $1996. Question A. In what 5-year period did the actual minimum wage increase the most? Thoughts? Okay. He says so far, so I'm going to take that to mean that he's not all the way through the numbers. Because Levi's comment was so far, he says 65 to 70.
Well, 530 to 623.
Oh, it's a whole homework.
Okay. So 210 to 310?
What are those bottoms? The same balance.
Yeah, the place that's kind of whited out there, it's still going to be the same pattern. And again, it's still, though, looking at the minimum hourly wage. And it's, 5-year period? So the biggest gap there is the 1975 to 1980. And so it's one of those things where something happened in 1975, in that time period, that caused a big jump in minimum wage. Okay? I'm not saying I can identify what that was. But, you dig into the history of that time frame and you can definitely find some kind of connection. Okay? In what year did a worker earning the minimum wage enjoy the greatest purchasing power? So as we check over here on the right, highest purchasing power happened in 1970. And I'm not the econ teacher or anything, but are you getting the idea of what it's meaning by purchasing power? Okay, so I mean, in easy terms, which is all I can really do with it, but how much can a dollar buy you? Okay, for instance, we know $1 now doesn't buy you nearly as much as what $1 used to, right? Just the difference in economy and that kind of stuff. So this is talking about the purchasing power and so, and I'm not saying that $1 buys you that much of stuff, but however they classify their purchasing power, which again, I'm not 100% sure on that, but just the purchasing power. The higher it is, the more you can purchase for a smaller amount of money. Okay, what was the longest period during which the minimum wage did not increase? And of course, this is according to this chart. What?
5 years, 2000 to 2005.
Okay, she says 5 years, 2000 and 2005. Did we have any place else that didn't change? Not according to this chart, right? So if we're talking 5-year increments, or longest period of time, we have a 5-year increment, that's all we know. So 5 years, and that was from 2000 to 2005. When it went up from there, we don't know. Not according to this chart, at least. Okay. Last question on this chart. A worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970. And yet there was great pressure to raise the minimum wage. Why? Okay. So minimum wage in 1970 was $1.60. Then 1980 it was $3.10. So just about twice that. Ashley?
Purchasing power is increasing.
Okay, purchasing power is decreasing. What'd you continue to say? Sorry.
As the minimum wage is increasing, the purchasing power is decreasing.
Okay. So $1 is going to earn or buy you less. Okay. So those people that are earning minimum wage are trying to make a living off of minimum wage, which is not an easy task. Okay. Some of you guys probably know that. But those people that are earning minimum wage, it's hard for them to provide for themselves, especially if that purchasing power is decreasing. And that is the key right there. So the why I have written in here, explanation you want in here, but okay, questions there? Okay, we're going to look at example 2. Example 2 is going to require the use of the graphing calculator. There's a couple different ways we can do example 2, but I'm going to take advantage of showing you what's the word I'm looking for? A skill, a technique you can use your calculator with, okay? The table to the side shows the growth in the number of prisoners incarcerated in state and federal prisons from 1980 to 2005. Is the proportion of female prisoners over the years increasing? And again, it's not that you have to have the graphing calculator to do this. You can do this on annual calculator to find your information. But again, I want to show you a skill on the calculator. But just in general, though, before we get there, what are your thoughts about what we're going to need to do here? If we are trying to answer the question, is the proportion of female prisoners over the years increasing? What? I don't know necessarily about making it into an equation, but
How come we can't just look at the table and see that it's only going up every year?
okay. So the question, why can't we just look at the table and see that it's going up every year? What is going up according to the chart that you can see just without doing any math?
The number of female.
Okay, everything's going up, but that's the number of female inmates going up. And the number of males are going up, and thus the total inmates are going up. Does that mean, what is the question here? Is the proportion of female prisoners increasing? So, in other words, well, I'm not sure how much I want to say here. I want to see if you guys. I'm trying to figure out what you're. I mean, we can think about setting up a proportion, yes. Although I guess I was thinking more of setting up a ratio. How are we going to figure out what proportion of prisoners the females make? Does that make sense? Am I asking the right question there?
I think but what I did was I divided my female by the total number.
Okay. So if we're looking at the female number of prisoners in comparison to the total number of prisoners, will that give us a proportion of how many, almost like, you can almost turn it into a percent. I wasn't going to turn it into a percent. But that gives you a ratio of how many. You did what? Ratio. And so the idea here is, yes, I agree. We want to do the females divided by the total. Okay, because we're looking at females in comparison to everyone. And which means we're not just doing females divided by males, we're doing females divided by the total. Now, you have your calculators. What is one option? Take your calculator and do the division 6 different times. Yes? Well, you want to see over the years if it's increasing.
Oh, over the years.
Now, okay. Now, and there's nothing wrong with that. This is not an impossible problem. However, as I said, I want to show you a way that the calculator can calculate that all at once for us once we enter the information. And in other words, what I'm showing you is helpful when you have lots of data. Okay? So, you got your calculators? Let's see. This is my class that has all TIs, don't you? So hopefully this will go pretty smoothly. Okay, so what we're going to use is we're going to use the stat and list functions. So I have a stat button. I'm trying to, right here, I'm going to hit stat, S-T-A-T. And it brings up a page that looks like this. Does your screen look like this? Okay. And then I'm going to go in, notice right now, highlighted is edit. So I'm going to go in, and I'm going to try and zoom this in so you guys can see a little bit better. Or more importantly, so Jacob can see a little bit better there virtually. I'm going to hit enter, and I'm going to go in and edit. Now, obviously my calculator has been used. I have numbers in my list. If your calculator has never been used and was brand new to you, I would like to think your lists are empty. Now, okay, well maybe I'm thinking wrong here. Okay, so here's the deal. First skill you have to know is how to clear these lists. Now, do me a favor. Do not delete the list because you can literally delete the L2 column so that it doesn't exist. And I don't want to delete L2. I just want to clear the data, right? So one option is you can go through and clear, delete every entry. But if you want to clear out the whole column, if I arrow up to where it says L2 and I hit clear, enter, notice it cleared all those numbers at once. I can do the same thing in L1. Go up to that heading and do clear, enter. You guys have blank columns. Okay, what needs to go in one of these columns?
The total.
Okay, we need the total numbers, like the total number of prisoners in one column, and what's in the other column? Females. Now, it'd probably be easier if we're consistent. Is it all right if I do females in the first one and totals in the second one? Technically, it doesn't matter. It's just on the next step. You're going to have to be very careful in which way you do this. So I'm going to put in L1, I'm going to put my females. In L2, I'm going to put my totals. So in L1, 13, enter. 23, enter. 44, 68, 93. What did I do? I have no idea what I did there, but somehow I ended up out of the program. 13, 23, 44, 68, 93, 108. That's one of your columns of numbers, right? Put your totals in the other column of numbers. If we've done this correctly, you have equal number of entries in both columns, right? And if you needed the men's numbers in there, could you make them a column too? Sure. Okay. We're not going to, honestly, this is the only question we have here, so we're not going to use the men's data, so I'm not wasting my time entering them. Okay. Are we all caught up there? Okay. So now I'm going to go over to L3. And L3 is going to be kind of what we're going to get as a result. It's going to be our results column. How do we get the proportion we need? What do we need to do here? We said we're going to do the females divided by the totals, yes? For me, that means I'm doing what column divided by what column? I'm doing L1 divided by L2. Is Levi necessarily doing the same thing? Not necessarily. You have to make sure you know where your females are and where your totals are. Now, what I'm going to do, go up into the heading of L3. Okay, we're going to go up into the heading of L3. And you'll notice right down here it says L3 equals. What do I want L3 to be? It's not just 1 divided by 2, it's L1 divided by L2. If you look down above your number buttons, for me there's blue. There's blue L1, L2, L3. And those are second functions, right? So I'm going to go second L1 divided by second L2. And so now, in my L3 heading, it says equals L1 divided by L2. L1 and L2 are second functions down on the 1 and 2 buttons. Second. Okay, yes, help each other. No. You want L1 to go here. That's right. Okay, now what happens when you guys hit enter? I haven't hit enter yet, but what happens? You get all the answers at once. Now, in this case, it took us more time, didn't it? Once you know how to do it, it could be quicker. You may say, that was a bunch of crap, Mrs. Sargent. I just want to do it by hand. I'm just showing you a technique that you can use. It's more helpful when you have lots of numbers, right? And once you know how to use it, it can be pretty efficient. And the nice part is I have all those numbers together. I don't have to arrow back up through all my calculator entries and see what was happening. Okay, did everyone all hit enter here? Your numbers match my numbers?
Yes.
Okay. If they don't, you probably accidentally entered something wrong. Now, I am going to write these numbers down when I move my notes here in a moment. But let's answer the question, then I'll write everything down. Is the proportion of female prisoners over the years increasing? Keep in mind, I entered the early years first, right? So as we look at those, are they increasing? Yes. Now, if you wanted to, up in that, when we typed in that formula, we could have typed in times 100. And then that would have made them automatically into percents, right? Same thing would be happening. But you can type whatever you want in that formula. Okay, questions here, other than I have to write some stuff down. Okay. Well, okay, so officially, yes. The answer is just yes, right? I'm going to write a little bit more than that because my philosophy is always who's going to be looking at my notes later. Okay. Your philosophy should be what's going to help you the most later. Okay. So my L1 was females. My L2 was total. So when it came to L3, I typed in L1 divided by L2. And I got these numbers here, 0.03951, 0.04582, 0.05685, 0.06044, 0.06686, 0.07077. And by me writing those numbers, that's kind of my evidence that is the proportion of female prisoners over the years increasing? And yes. And I'm just going to say, as shown in L3. So, that skill is not a skill we use a ton. Okay? But, hopefully it is helpful. Okay, you guys got what you need there? And I guess if nothing else, by writing this information down, maybe you can figure out how to do a list later on. If you want to clear the numbers out of the column, if you go up to the heading, hit clear, enter. Otherwise, I think if you want to go to each individual entry, you can delete them individual. But here's, I am very specific about clear versus delete because you have to be careful. If you delete a column, like if you delete the L2 column, it's not the end of the world. You can go on without the L2 column. There's a way to get the L2 column back. I just never remember what it is. So how do you hit clear to get out of the Yeah, you should, to get out of here altogether, you should be able to hit clear, or I always do a second quit if I can't get out of something. If I'm stuck and can't get out of something, like, I think my general idea is I go to clear. Clear doesn't always work, as you've learned. So a second quit always takes me back to the home screen. Sorry. And this is, guys, ask these questions, like, how do you get out of there? Because that will trigger me to give you things that I do. No.
I thought it was going to be like...
No, quit is not a bad thing on these calculators, okay? Okay, so you don't have to use reset every single day now? Is that what I'm helping with, baby? Again, the calculators are a learning process. I will continually, as the year goes on, tips will come up here and there. So, okay. It was all numerical. It was all based on numbers, analyzing numbers. On the next page, we're going to start talking about algebraic. So when you talk about algebraic, we're talking about formulas now. Okay? A mathematical model that uses formulas to relate variable quantities associated with the phenomena being studied. It can then generate numerical values of unknown quantities by relating them to known quantities. Okay, so think algebra. Okay, think formulas here. Let's talk about the pizzeria. Okay, a pizzeria sells a rectangular 18-inch by 24-inch pizza for the same price as its large round pizza, 24-inch diameter. If both pizzas are of the same thickness, which option gives you more pizza for the money? Did you say those are big pizzas?
Those are huge.
Okay.
He works in the You might be
That's true because I was with my parents this weekend and they ordered a large pizza, a large and a medium. The medium was 12-inch and the large they gave us was 20-inch. We had wanted a 16-inch, so I think they gave us an extra large or something. But we had extra pizza, so I wasn't complaining. I mean, my parents sent home pizza with us, and I can't complain there. So, okay, sorry, we shouldn't be talking about food. Lunch is a couple hours away. Okay, thoughts, and how do we know which pizza is the better buy? Find the area, and we can just talk area because
The same thing.
They're the same thickness. If we need to talk thickness, thin crust versus thick crust or something, then we might have to talk volume, or we're going to talk area. So we have a rectangular pizza, right? How do you find the area of that rectangular pizza? Length times width? So length times width on that rectangular pizza is going to be 18 by 24. Notice it's all in inches, so we'll just be talking inches. What was 18 by 24? Okay, 432. And that's going to be 432 square inches, right? Area square inches. Now, let's double check real quick. Did they give us inches on both? Yeah, we need to compare apples to apples, not apples to oranges, right? So you want to make sure you're all in the same unit. Okay. We also have a round pizza. What's the area formula I need now? So, area of a circle is what we're talking about. And guys, this is a formula you just need to flat out know. I saw a good handful of looks of, oh no, I don't know this one. I could tell the look. So, pi r squared is area of a circle. So, what's that mean I'm doing here? What do we use for pi? Okay, pi symbol, or if you don't have a pi symbol, 3.14, which we do have a pi symbol on these calculators, so. R.
24.
It's 12.
12, because it's spelled, oh yeah, it is 12.
Okay, so I heard 24 and 12.
It's,
Why don't you guys fight it out here?
it's 12.
It's 12 because we need the radius.
Yeah.
If the diameter is 24, that's all the way across, so the radius is half of that distance. So pi times 12 squared. On these calculators, you do have a pi button. It's a second function of your exponent button. So it's over there on the right underneath clear. Or you can just type in 3.14. Oh, it does give you two different answers. Not that it really matters, but
So did we just do 5 times?
yep. Depending, whoops, got a glare there. Trying to get rid of the reflection some. Depending on which scenario you typed in, notice your answer is slightly different, yes? If you used 3.14, you got 452.16. If you used actual pi, 452.3893421. Now, in this scenario, they both give me a good enough answer because it will be enough to answer what we want. Technically, they're both correct. Sometimes you will see in certain problems, they may give you, use pi, or if you see in a problem, use pi as 3.14, that's saying they don't want you to use a pi button. They want you to use 3.14 so that everyone gets the same answer. So occasionally you will see that. Guess I'm off the screen a little bit because I zoomed in for the calculator. So whichever answer you write down doesn't really matter to me. So if both pizzas are of the same thickness, which option gives you more pizza for the money? Round pizza is your better deal here. And I don't really feel like I need to give an explanation because my work is my explanation right there. And we've talked about it. Okay. We're going to go ahead and delve into graphical models. I'm not sure where we'll exactly get caught at the end of the period. By the way, page 74, the homework assignment, is not due tomorrow because I know for sure I'm not getting through all my notes today. Okay? I knew I was not getting through the notes before class ever began. So, it doesn't matter how off task we get or how on task we stay. So as of right now, I have the homework due on Thursday. FYI. Okay? Doesn't mean you can't get started on it tonight, right? But, okay. Graphical model. Graphical model, a mathematical model that gives a visual representation of a numerical model or an algebraic model that gives us insight into relationships between variable quantities. Okay. Hopefully your calculators are still close by your side, because we're going to use them again. Galileo Galilei spent a good deal of time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. His experiments are commonly repeated in physics classes today, so it is easy to reproduce a typical table of Galilean data. The question here, what graphical model fits this data? Can you find an algebraic model that fits? So we're going to use our calculators to graph this data. Because I want to know, is this a linear model where the data forms a straight line? Is it a quadratic, a cubic, exponential? Okay, that's what we're going to be looking at here, is looking at the graph and trying to figure out what this graph looks like. Okay, so what graphical model fits this data? I have numbers, and I just told you guys I wanted to graph this. What? We will make an equation, but we're going to graph this before we have an equation. Okay, so, okay, you know how I introduced L1 and L2 a little bit ago, yes? Okay, so we're going to be talking about L1 and L2. We're going to be using L1 and L2, so you're going to head back in there. We're also going to use this thing called stat plot, which some of you I've had to turn off your stat plots because it was interfering with your graphs, because you guys have, I'm assuming, played and turned them on. So I've been doing that. Well, we're actually going to have to turn a stat plot on, and that's how we can graph a set of dots. Okay? So, we're going to do as much of this problem as we can today. If I get caught in the middle, just don't clear the stuff off your calculator, you know, because you won't probably be using L1, L2, that type of stuff. And we'll work on it tomorrow. So, let's see. First thing, do you remember how to get into L1 and L2? Go into L1 and L2, hit the stat button. Sorry, this volume is obnoxious. Okay, stat. All you have to do is hit stat. It brings up this screen, yes? And then I'm going to hit enter to get into edit. Now, I did not clear my data earlier. So I'm going to have to do that now. I'm going to go up into each heading. L3, clear, enter. L2, clear, enter. L1, clear, enter. All of mine are empty. Are yours empty?
Yes.
Or if they're not empty, just go use L4 and L5, but eventually you run out. So you have to clear at some point. Okay, so what should we put in L1? Elapsed time. What's that mean is going to go in L2? Distance traveled. Work on it. So L1 is my top row. Which is 0 through 8 pretty much, isn't it? L2 is going to be my second row. I can feel somewhat confident that I entered my numbers right if my rows end at the same place. I would check to make sure that none of your numbers seem crazy, weird, you know, like you forgot a decimal or something like that. Okay, do we have those numbers entered?
No.
I think I should have restarted my computer this morning. It's being exceptionally slow. Okay. Are we good there? Now, we want to see what these dots look like when we graph them. If you just hit graph right now, they're not going to show up because I equals and clear out any equations you have here. We don't want those right now. Okay, so make sure your y equals is clear. Now I'm going to do a second quit to get out of there. Repeat that helpful hint that some of you need, it appears. Okay, so above y equals is the heading stat plot. Do you see that? It's above it, so it's a second function. So I'm going to hit second y equals. And it takes me into stat plots. Notice all of my stat plots are off, as they should be. Go into number 1. So just hit enter when you're on number 1. And toggle it over to so where it says on. Now, before you go out of there, one thing you'll want to make sure. Where did I enter my data? I entered my data into L1 and L2. I entered my top row into L1, so my X list should be L1. I entered my bottom row into L2, so my Y list should be L2. You can play with the other stuff. You don't have to. But now that I've turned this on,
Wait, did we press enter when we convert over the on?
yes, like arrow over, I think, and hit enter.
Yeah.
Okay. Now, if I hit graph from here, what do you see? Besides my camera doing crazy focus things.
Little squares.
Okay. Little squares. What do those little squares represent? Those are my dots. Notice I have a little square at 0, 0.
Yes.
My next square is at 1, 0.75. 2, 3, 3, 6.75. Are all of my dots visible?
No.
No. Why not?
Because it only lists 10.
Okay, so next thing we're going to do. Go to window. Okay, you could zoom out, but to me it's not going to work as well. More efficient, go to window, which is the top row, and it brings up this screen right here. Okay, do I need X min, X max? That's how far left and right my graph goes. Do I need my graph to go all the way left to negative 10?
No.
Really, it only needs to go left to 0, because I don't have anything negative, do I? X max. I think my biggest X value is 8, isn't it? Looking at my chart. So I'm just going to leave it at 10. It's fine at 10. The X scale just says my graph counts by ones. It's fine. Okay, Y min. Do I need my Y min to go negative? No, I'm going to put it at 0. So this means I'm only going to be looking at first quadrant. Y max. How high do I need my Y graph to go?
48.
Minimum 48. I like round numbers, so I'm picking 50. Okay, I like that setting better. Now hit your graph button. And that's a much prettier picture, and we have all the dots now. Okay. Any thoughts on what shape you're looking at here?
Curve.
It's a curve. What kind of curve?
This is upward sloping curve.
X when it,
I can't tell if anyone's... Okay.
It starts at 0 and goes up. So
There's a specific name for this curve, because we're looking at part of a parabola. Okay. Darn it, I thought I had another minute. Okay. We will pick up on this problem tomorrow. If you can, leave that information in your list. If you have to graph something tonight, you need to go in and turn that stat plot off. Okay? So, we will come back and finish up that problem and more tomorrow.